Hello and welcome to today's PIR live event webinar, special for Computer Science Education Week and brought to you by Partners in Research Canada. My name is Stacey Joyce and I will be your host. If you're joining us live, please make sure that you find your way to the Q&A button at the bottom of your Zoom window and let us know what it is that you're wondering. We would love to bring those questions up a little later on and we'll relay them on your behalf. We'd love for you to include a little bit about yourselves, whether that is the teacher's name or the school name or maybe what city the question is coming from, so we can give you a shout out and you can be certain that that is indeed your question that we are asking. So today's guest is Renée Higgins. She's a graduate of Laurentian University and a web developer with 10 years of experience coding numerous projects from apps to games and websites. So thank you so much for joining us, Renée. I will let you take it away.
Great, thank you so much, Stacey. As Stacey mentioned, I am very excited to be here. I volunteer a lot in the local community. I am very passionate about coding and I've taught a lot of computer classes on a volunteer basis. So I really like sharing what I love about coding and why it's such a great skill and a great field to consider for future career paths too. So before I get started, I know there's a whole bunch of different ages and skill levels in the room, so I'm just going to give a 30-second overview of what code is. Code is the language that we use to talk to computers. It's how we tell computers what to do. Computers aren't as smart as we think they are. They need very, very specific instructions, but once they have those instructions, they can execute them faster than any human can. You ever tried playing cards online? The whole computer can shuffle the deck in just a few split seconds. What human can do that? So it's really just trying to think about how many times in a day are you interacting with things that are run by code? Somewhere, a computer programmer coded something, and that's what you're seeing when you look at your mobile phone, when you look at your computer screen, when you're playing games, when you're looking at websites. That all was manually built from scratch by a computer programmer somewhere in the world. So it's very exciting. Computers are not just laptops, they're not just PCs, they're not just things with keyboards. Phones and tablets, gaming systems, all of those are computers too. And even a lot of the appliances that you have in your house, like your oven and your microwave, have computer chips inside them. Any app that you're running on your phone, if you're checking out at a grocery store or a pharmacy, that cashier is using a computer system that was built by a coder. So code really is just everywhere, even when you don't realize it. And the amount of code that exists in this world is growing faster than any other thing right now. So coding is amazing. It's super fun. There's a major shortage actually across the world, but especially in Canada for coding talent. So what that means is that it's a very great field to consider for a future career path. It's very easy to get a job. It pays very well. And once you know code in one language, it's really easy to learn others. So I was hired before I even graduated from university, and it's not necessarily something that you need a degree for, although that does help get you kickstarted faster. I had a full-time permanent job with benefits that paid well. Some of my friends couldn't find things in their fields, so I think that's something very important to consider and something that I wish someone had told me when I was younger. So how did I end up in coding? It was actually an accident. So I wanted to go into biology. I had registered at Laurentian University in a field called forensics, which is kind of like this police side of biology, if that makes sense, like fingerprinting and stuff like that. But I had to take an elective class. So I chose what I thought was a bird course just for fun. And I accidentally registered for a really hard computer programming course. And I had never coded in my life. I ended up falling in love with it. My second week, I changed my whole career path and switched to a full-time major in computer science. Coding is amazing, and it's a valuable skill no matter what you end up doing. I always tell people it's an amazing career path because I do strongly believe that, but it teaches you valuable problem-solving skills. And no matter what field you go into, coding is a useful skill to have on your back burner. There's almost always going to be a time when something comes up in your life that you wish that you knew code and that you could do it yourself. If you want to build a website about your business or something that you love, you can totally do that if you know how to code. But most of all, coding is just fun. I used to, for fun, build like crossword puzzles and puzzles, play games on my phone. Sometimes for fun, I build code. So it really is something that I truly enjoy. And I wish that I had been exposed to it at a younger age, because I immediately fell in love with it. And I feel that if I had been able to learn it in school or at a younger age, that I would have known more early on what I wanted to do. So what do I specifically do with code today? I'm actually a web developer, so I did that for 10 years. What that means is that I build websites from scratch. So I put together pieces of code, and then that creates the website that you see on your computer screen when you go to them. So all websites have that code behind them that most of the time was built by a web developer like me. What kind of jobs are there in coding? The opportunities really are endless. First thing I want to mention is that coder, computer programmer, software developer, software engineer, those are all basically the same thing. They're all coders. They all do some type of code for their daily job. But there's lots of different career paths you can do in computer science. That a lot of people don't realize. So you could be working at a help desk resolving computer issues for people. You could be working in hardware, building computers and physically building these things, putting them together. You could be supporting some phones, cell phones and desk phones, things like that. You could be administering the network and internet for someone. You could be a software developer, a web developer. You could be building games, project management. So the jobs in IT really are endless. And you'll find that if you get kind of tired of something, there's always something else to head towards. So I think it's just a super exciting field. And the other thing I want to mention is whatever you're passionate about, there's always a tie-in with coding. So I'm really passionate, for example, about healthcare. So if I wanted to, I could go and work for an IT department at the hospital and work on electronic health record systems that help to keep people's records up to date. Or I could build an app that helps people in the ER know how long the wait times are and how long till they're the next ones to be seen, kind of thing. So there's always that tie-in. You can work from home, you could work for a business, you could do anything you want. I build websites on the side, so if I have a weekend where I don't have anything going on, I'll build a website for someone, and it's super fun work that pays really well. So one of the students I went to university with actually works for NASA today. So he's a computer engineer with NASA. He literally builds computers that go on rocket ships. Some of my friends do remote work, so they go and they sit in coffee shops, and they all meet up together every morning and have their coffee, and they code at their laptops in the coffee shops for companies all over the world. And so they get Canadian holidays and US holidays off, which is pretty cool. My brother-in-law actually built some of the software that goes in the traffic light systems at the city of Ottawa. So if you're driving around Ottawa and you hit a red light, that could be his fault. I have another friend that worked on the Call of Duty game line, which is one of the top games in the world right now. So literally the opportunities are endless. If you have an idea of something that can make someone's life better, having those technology skills can help you either build it yourself or have a better understanding of where to go to get that built for you. So try to think about what makes you happy. If you love what you're doing, you never work a day in your life. I really believe that. Think about what makes you happy and whether there's a way to tie code into that somehow. So I just want to show you guys a little bit, get you excited about coding, and really get you realizing that anyone can code. I hope that some of you are already familiar with Scratch, but if you're not, I'll be going over a little bit of how it works to give you an idea. So let me just share my screen here. So hopefully you can all see this okay right now. So one of the organizations that I volunteer with is called Canada Learning Code. they have different branches. They have kids learning code, teens learning code, girls learning code, teachers learning code, all kinds of great stuff. And one of the cool things that we do is we build games. So these games in like 3 hours, people that have never played before can build these great games. So this is an example of a game that one of our students built in 3 hours. This person had never coded in their life, didn't even know what code was. And using Scratch, they were able to build this great game. So because there's sound, I'm just going to play it one more time so you can kind of see what's happening. So they had this little character, and you're supposed to go around and touch things, and as you touch them, your collected goes up. And if you hit something bad, the character says you've been juiced. So the goal is to kind of go around and try to catch as many things as you can without touching the bad things. So I'll play it again. So the bananas are good and the oranges are bad. This is an example of a game that was built using Scratch. If you haven't been to Scratch before, it's a great tool that I highly recommend. If you just go to your web browser and type scratch.mit.edu, you'll get to the website. And any project on the website, you can hit this little see inside button and see the code that was used to create that specific game. So I'll show you an example of another game that we built in 3 hours. This was built by kids in grades 4 to 6 in about 3 hours. So in this game, I don't know if you ever played Flappy Bird, but it's basically like Flappy Bird. So when you hit your space bar, your character goes up. And when you let go of the space bar, your character falls. And if you touch any of the caves, you lose the game. So I thought it'd be cool to just show you how quickly a game like this can come together. And then I'll move on and show some of the projects that I've built on my own, and then open it up to some questions later on at the end. So in the Ladies Learning Code accounts, we have a whole bunch of starter packages. So this is an example of the superhero starter. And you can take this, and it just has all the graphics that you need and the boring stuff set up already so that you can get into the really fun code. So if I go ahead and look inside this project, I can remix it. So this is now saving the project to my own account so I can go and do whatever I want with it. So if I click on the little cat at the bottom here in this sprite screen, I'm just giving an overview for those that haven't used Scratch before so that they understand how it works. So by clicking on this little cat, I'm able to change the code that controls that cat. So on the left here in this purple area is where my game is, and on the right in the gray area is where the code goes. And then there's all kinds of different categories of code blocks in the middle. So if I go to the events category, which is the dark orange stuff, there's this when green flag clicked option. So I just click and drag that into my coding block. And this means that when this green flag is clicked here, that starts off my game. So this is one of the beginner blocks that's used in almost every single game. And I'm just going to piece together 10 lines of code, and you're going to see the difference that just that can make in this game. So in the motion category now, I'm going to grab this go to XY. You may have learned about XY coordinates in schools or in your school already. It's just trying to set a starting location for the cat. So when the green flag is clicked, I want my cat to start where he is right now, over here. So if I move the cat here and hit my green flag, he always goes back to that start position. So when green flag clicked, go to my start position. Now in the starter package for this game, there's already a function that changes the background as the screen moves. So to link back into that and get this going, I'm just going to start my game off by setting the distance traveled to 0. So every time when I start my game, I want to restart my distance that my cat has gone. It's just kind of a variable to store where we're at right now. But as the game moves on, so I'm going into my control area here to grab a forever block. And again, I'm only going to put 10 blocks here just so you can see what happens. So forever, as the game goes on, I'm going to change my distance traveled. So what this means is that as the game goes on, my cat's going to move across the screen because that distance traveled is always going to be changing. The only problem is this change distance traveled is only changing by 1 pixel forever. So as you can see from my game here, the cat's moving pretty slowly. So all I have to do is change that 1 to something a little bit higher. So if I want my cat to move by a bigger chunk every time, I just change that to a 5. And now when I hit my play button, you can see my cat's moving 5 times as fast. So the neat thing about Scratch too that I always encourage people is you don't have to copy exactly the same code that everybody else is doing. You can use it to literally make the game your own. If you want your cat to move a lot faster, you could make this a higher number. And if you want them to move a lot slower, you can make it a lower number. So it's really flexible and really lets you do your own thing. So the next block I'm going to grab is a really functional block. It's called an if then else block. So this is kind of a condition. So if something happens, then do something else. So otherwise, do something else. So these blocks here, these holes, mean that I can put something in there. So I'm going to go ahead and add a couple more blocks to this, and then we'll run it to see what happens. So if you've ever played Flappy Bird before, you know that things happen when you press the space bar. So I'm going to go ahead and grab that. So in this blue sensing category, there's a bunch of options for different keys that can be pressed. So I'm going to grab this if key space pressed. So if my space key is pressed, then I want my cat to move up. And if the space key is not pressed, I want my cat to go down. So the way that I do that is by going towards the motion category. And I'm going to grab this change Y. So when you change the Y, that makes your character go up and down. And when you change the X, that makes it go left and right. So I'm going to change Y by 10 to make the cat go up when the space key is pressed. And when the space key is not pressed, I want my cat to go down. So I'm going to go by -10 to make it go down. So let's go ahead and give that a try. So when I hit my space key, the cat goes up. And when I let go of the space key, the cat falls. So you can kind of play around with those numbers too to get different speeds for your cat to rise and fall. And then 2 more code blocks and my Flappy Bird game is done. So again, you can see how quickly this is all coming together. So I changed my 10 to a 5, and now my cat's moving a little bit slower. So it's a little easier to control because I want to be able to get my cat to go through the caves and around the caves without touching them. So right now, when I'm touching the caves, I've lost the game a few times there, nothing's happening. So that's the last piece that I need to build in, is a way for me to know when I've hit the cave and for the game to stop when that happens. So the last block I need for my Flappy Bird game is if I'm touching a cave, then tell me I've lost the game. So I grab this if then block. You kind of already have an idea of what that does from the block that I've used previously. So if I am touching the cave, so the way I'm going to do that is the touching color option. So if I'm touching, not purple, but this green color here, so all I did was click on the color and then click what I want to change it with. Then I'm going to make my cat say that I've lost. I'll do this. So let's go ahead and try that game again. So my cat's going around. I'm moving kind of slow. I could speed this up if I wanted, but I'm not very good at this game, so I'm going to keep it slow. And then say I accidentally touch a cave, the cat tells me that I've lost the game. And that's Flappy Bird. So it's hard to believe. Like, there's more things you can build in. Like, you could have it speed up every time you win. You could make him say you win when you hit the finish line. But for the sake of brevity, I'm going to leave it at that for now. Don't forget, on Scratch, there's all kinds of great things in the Explore tab. You can go see what other people have done. And anyone that you like, that you're interested in seeing the code behind, you can click on it and then hit that See Inside button, and it'll show you all the code that's inside it. So once you've played around with Scratch and you kind of have an idea of some basics, if you really want to get excited about coding, there's this website called Code Academy, and Stacy's going to send out a link to all the webinar participants that has these websites in it as well. So you'll be able to access the things that I've referenced. But in here, there's all kinds of courses. So I build websites, and if you go to the catalog, you can learn about web development, or you can learn about HTML and CSS, which are the languages that are used to display websites. So in here, you can go ahead and click on any of these items, and it'll kind of give you a step-by-step way of learning what the language is and how it works. So it's very similar to Scratch in the sense that the code is on one side, and on the same screen, you can see what's happening over here. So it's just kind of guiding you. All the instructions are on the side, so I'm not going to get too detailed with this, but it explains what it is, what's happening, and then they give you instructions. So in here, it's saying type your name between H1 and H1. I'm going to type Renee, and then when you hit run, you can see on the right side of the screen how it renders. So you can go ahead and keep editing, keep hitting run. And when you've accomplished the goal of this lesson, the next button becomes available for you to click. So you can click on that next button and keep going, keep learning. And if you want to learn how to build games, mobile apps, websites, programming languages, that's all in here. And most of the courses are completely free, but if you want a pro account, you can ask your parents for that for Christmas. But there's tons of really great free stuff on here. This is really one of the best ways for you to get started with coding. If you ever have the opportunity to take computer science electives in elementary school or in high school, I really recommend that. But learning on your own is the best way to learn how to code. A lot of the stuff that I learned was on my own. Because I just kind of fell in love with it and didn't know anything about it. And everybody else that was already in computer science had been doing it for years. So I was able to do a lot of catching up on my own time. What I love about building websites, so I'll show you an example of a website that I built. This is the website for the city of Greater Sudbury. So this is the city that I live in. I work with the municipal government. And I had the opportunity to build this when I was in IT. A designer kind of came up with the concept for the design, and then I built it with code. I kind of brought it to life so that when you click on things, things happen. And so that staff could edit the content of the website. So the neat thing about this website too is that it uses something called responsive design, which means that as your screen size changes, the website automatically adapts. So whether you're on a tablet or a mobile phone, the website's always kind of optimized for your screen size. But one of the things that I love most about building websites is that every website is completely different. It totally depends on what the client or your friend or yourself, what you want to do. And so every single one is like a blank canvas. You never know what you're going to end up with at the end. And everyone's completely different. And I get to work with teams of people. I get to work with content editors and graphic designers, and we're all kind of experts in our own areas that come together to make this happen. And the neat thing about code is that, as I showed you earlier, every line that you add, you kind of have immediate gratification. You see a result happening as you're building it, which is something that I really loved. That was, for me, what makes coding so fun. It's literally like putting a jigsaw puzzle together, but you don't even know what it's going to look like until you're done it. So I absolutely love it. And another reason I love building websites is that I'm really passionate about business and marketing and strategic research, those kinds of things. So this was a perfect way of bringing all my passions and skills together towards a common goal. So that's kind of all I had planned for today. I'd really like to leave a lot of time for questions, just in case there's anything that anyone wants to ask me about. You can ask me about school or work or what I do for fun, whatever you'd like. So I'll pass it back to Stacy so that she can coordinate that part.
Thanks, Renee. That was a lot of great stuff that you were able to show us. I was hoping you might be able to go back to showing one of the Scratch screens and just sort of that library, those little blocks that you click and drag. Where do those come from?
Sure, we can go back to that. So in Scratch, these blocks here in the middle, these are kind of the database of what's in Scratch. So Scratch is kind of, instead of having to manually type out all of the code, you get to use these blocks that people have already put a whole bunch of code behind, and it makes things come together a lot faster. So you can focus on the fun logic side of coding, and the typing that all comes later. So these blocks that are in the middle here is just kind of a central repository of everything that you can do in Scratch. And these categories at the top here just kind of organize all the different blocks together. And it really makes a lot more sense if you're actually in Scratch using it. For the teachers out there, if this is a tool that you could see your class really benefiting from, there's a lot of great resources on the Teachers Learning Code website. There's free 1-hour step-by-step lesson plans to help you, even if you've never coded before. You can walk your students through something like I just did today. And when they're actually getting to click and drag everything, it's a lot more fun. So looking at this game here, this is another one of the games that was built at one of the Kids Learning Code workshops. The bananas drop from the ceiling there. So over on the right side here, you can see some of the code behind that. So when the green flag is clicked, my little sprite here, this character, starts off at this position. And then when the right arrow is pressed, he moves to the right by 10. When the left arrow is pressed, he moves to the left by 10. So you can use the arrow keys to move them around. And that's another really cool thing about the code in Scratch is that when you look at the buttons, they literally mean what they think you mean. And to talk a bit more about the buttons themselves, the shape of them kind of gives you a hint at where they might be able to go. So you see how this if-then block is kind of like a puzzle piece. There's a little chunk missing from the top and an extra chunk on the bottom. That's how you know that it can fit into other things, just like a puzzle. And these sensing keys, they have pointy sides, and the if-then block has a pointy slot. So that's how you know where these different types of buttons can be dropped into and where they go. And then it all kind of builds together. Another really cool thing about Scratch is that right within it, over on the right side, it's a little bit hidden, but there's a question mark. And when you click on that, all kinds of tips pop out. And there's lesson plans, things like that. So anyone that wants to get started with coding, you can click on that and try to find something that you're interested in. So this Make It Fly is actually very similar to the Flappy Bird game I just showed you. But if you want to learn how to create a Pong game, for example, you can click on that, click here to start, and it'll give you step-by-step how to build the games. So it'll say, okay, choose a backdrop that you want, and you can go in and follow the instructions that are there to go and pick the backdrop that you want for your game. So it'll tell you. Yeah?
Sorry, I didn't mean to interrupt you. There seem to be lots of things then that are built out. There's this library or repository of things for students or anyone to draw from. Is that right?
That's right. Yep.
Wonderful. Well, I do have several questions that have come in from the students, and I'd like to get to those.
Okay.
So go ahead and click the stop share button for now, at least. And we have a question from Ms. Lowe's class, wondering what is the most popular game that you have done coding for?
So I build websites, so it's a little different than games. Probably the Flappy Bird game that I just showed you is one of the most popular ones that kids really like. But I've built a lot of websites. I have my own website. It's kind of like a website where people can sell equipment for mining, construction, and industry. That's probably the most popular thing that I've ever built. It's not super exciting to look at. It's a bunch of forklifts and trucks and things like that that people are selling. But it's called equipifieds.com, and that's probably the thing I've built that's got the most traction, other than the city website, which I worked with a great team of people to build a couple of years ago.
Wonderful. Next question comes from Ms. De Bruin's class. How was code invented? What was the first code, and how did they come up with it?
Interesting. That's a great question. So one of the things that I love to say is that we don't really know exactly when coding started. It's very difficult to say, and the reason why is because the very first computers that existed are actually, and everyone has different opinions about this, but one of the most common accepted answers is that it's the telephone equipment that was used during the First World War. And that equipment was actually manned by women because most of the men were off fighting. And there was one woman, her name was Mrs. Lovelace, and she's considered one of the first computer programmers. And many of the women in those wars were also considered programmers. So they would just kind of redirect calls to different boards as they were coming in, and basically manning computers very, very manually at the very beginning.
Well, right in the middle of that answer, you also answered our question about the first coder from Eden, who's a grade 7 student at St. Michael's School. So good timing on that question. We have a question from Lewis in Toronto wondering, how many websites have you made?
Interesting. Well, in school, I probably made like 20 websites. Some of them were like super easy websites that took maybe a weekend or a week. But in my career, most of the websites that I've built took a really long time to build. So the city website from start to finish took about a year. I was doing other stuff too at the same time, but you can see how as websites become more and more complex and take longer and longer to build, the amount of websites that I produce now is a lot lower, but they're a lot bigger and do a lot more. So maybe in my whole life, I built 50 websites. Most of those aren't live anymore, or were just for schoolwork, but yeah, that city website's probably the biggest one that I have that's still live.
Right, thank you. Follow-up from the same class, Ashvin in Toronto is wondering what website you made that has the most traffic.
Ooh, well, definitely the city website. I wish I could remember offhand. I know it has a few million views a year. So I want to say it was like 5 or 6 million page views a year. So that's quite a bit of traction.
Right. And next we have a question from Ms. Vickers' class and Michael at St. Michael's School in Ridgetown wondering how many hours go into coding and creating a game?
Michael has a class, a whole school named after him. That's pretty cool. Lots of hours. So it depends on the type of game. If you're using a tool like Scratch, you can build something very, very quickly, build together these types of things. But then you can only use it in your web browser. So it depends how your game is going to be used and what the complexity of it is. So you can build Flappy Bird in Scratch in half an hour, 3 hours. I know somebody built Mario Kart in Scratch, and that it took them many, many months to do that. And if you go and look on the Scratch website and search for Mario Kart, you can see inside and look at all the code that's there. And there's thousands of code blocks. So it really depends on the complexity of the game you're building. Some of the games that you guys play on your gaming systems or mobile phones will have taken years to put together by huge teams, hundreds of people. So there's totally different scales depending on the type of game that it is.
And I should just do a little plug here. We have another webinar coming up later this week. It is on Thursday at 11 a.m. and we're going to be talking specifically about video game design and production. with another coding expert. So that's something you might want to consider if you have lots of questions for a gaming expert in particular. We do have a couple more questions I want to squeeze in. The first one from the students at St. Nicholas in Mrs. Boncardo's class. They want to know if you pick and choose which websites you make, or are you willing to do anything that comes your way?
Well, it depends. So in my own business, I can pick and choose which projects that I want to take on. And then in my work, that's typically decided by the organization. So they tell me, okay, we need a new city website, or we need an intranet, or we need a website for this organization. But what's really fun and what I really enjoy about having my own business is that I can pick and choose the times that I want to work and where I'm going to work from, and what projects I'm going to take on. So technically I'll take anything on. I really like that every single website's different. I do a lot of work with charities too. And that's what's most exciting, is being able to give back to the community with that kind of stuff too.
And so obviously the city that you work for is going to have particular needs that they bring to you. Is it a back and forth conversation at all about how to realize what it is that they're envisioning?
Definitely. So normally what happens is the client or the employer has their business requirements, and then the coder, the web developer like me, gets to decide what steps, what technical process, how it's going to happen. So even though they want a city website that's user-friendly and mobile-friendly, there's a lot of flexibility in how that's implemented, and it's totally a back and forth conversation. There's so much opportunity to contribute and give ideas to, because as a web developer or a coder, you have a better idea of what's possible from a technical perspective. So you kind of build on each other's ideas back and forth. So they're like the business expert and you're the technical expert, and together you come towards this common goal, which is trying to achieve the best possible website or whatever the project is.
Right. And so the last question I wanted to put out there, since we've already run over time, is from Ms. Hooworth's class. What kind of advancements do you see with coding in the future?
So that's actually super interesting. Is a lot of people are talking about smart appliances, smart traffic, things like that, like traffic lights that will automatically turn green when there's accidents or constructions or ambulances, things like that. Smart traffic systems, that's supposed to be like an up and coming thing, and some cities in Canada already have it. Smart appliances, so like a fridge that knows when you add a carton of milk in it and knows when you don't put it back, so it knows that you need to order milk and it automatically adds it to your grocery list. Or the fridge knows when your eggs are expired and has to be thrown out. There's all kinds of really cool things coming with what we call smart technologies. So smart traffic systems, smart appliances that can kind of think for themselves, but there's a coder behind the scenes that's coded all of that to happen. And that's the reason that there's a huge amount of coding jobs needed, and the amount of computer science graduates is kind of staying steady, but the need for coders is going up and up and up. So anytime you have that demand gap, that's when you know that you're headed towards a great field. And technology is constantly evolving. If you Google on YouTube, like the way of the future, things of the future, ideas for the future, there's all kinds of really great videos that will show you where technology is heading.
Well, thank you so much. That is all the time we have, but I'm sure I can speak for those who are able to join us now and those who will watch this video later when I say thank you so much for sharing your passion for coding, some information about where students could go if they wanted to pursue coding as a career, and for answering our questions today.
No problem. I had a great time, and thank you so much for the invite.
So just before I leave us today, I want to remind everyone that we have more upcoming PIR live event webinars this week for Computer Science Education Week, and there are more webinars beyond that as well. You can certainly check out the schedule and other educational programming at pirweb.org. Thanks for tuning in today, and we'll see you next time.